Now we start the second part of this presentation, titled Relationship between Resource Use and Human Activities. From the often occurring situation that the higher the income due to industrialization, the higher the environmental impact might be, we can conclude that the number of inhabitants is not the main problem of environmental degradation, but rather their consumption and production patterns. What we need is a long-term vision for inter- and intra-generation equity if we want to ensure a sustainable development. And what we first of all have to meet are the basic needs of the whole population. That means health and education services, like we have experienced with the COVID crisis, as well as food, shelter, and clothing. Over the last decades, we have seen significant improvements in cleaner production. That means in pollution prevention and waste minimization, mainly at the production level. However, changes in consumption patterns have offset the environmental gains achieved through cleaner production. Let me now explain you the so-called IPAT equation, which is the mathematical notation of a formula put forward to describe the impact of human activity on the environment. I'm sorry, but this will take a moment. The expression equates human impact on the environment, short I, to the product of three factors, short P for population, A for affluence, and T for technology. Critical raw materials play an important role in technological development that contribute to transmaterialization through, for instance, energy efficiency, dematerialization by the use of high-tech, and structural changes by overall technology development. The variable I in the IPAT equation represents environmental impact. Multiple categories of environmental impact, such as climate change and eutrophication, can be accounted for. The variable P represents the population of an area, such as the world. Since the rise of industrial societies, human population has been increasing exponentially. The United Nations project that world population will increase from 7.7 billion in 2019 to 9.8 billion in 2050 and about 11.2 billion in 2100. The variable A in the IPAT equation stands for affluence. It represents the average consumption of each person in the population. As the consumption of each person increases, the total environmental impact increases as well. A common proxy for measuring consumption is through GDP, per capita, gross domestic product. While GDP per capita measures production, it is often assumed that consumption increases when production increases. GDP per capita has been rising steadily over the last few centuries and is driving up human impact on the environment in the IPAT equation. The T variable in the IPAT equation represents how resource-intensive the production of affluence is. How much environmental impact is involved in creating, transporting, and disposing of the goods and services used. Improvements in efficiency can reduce resource intensiveness, reducing the T multiplier. Since technology can affect environmental impact in many different ways, the unit for T is often tailored for the situation to which IPAT is being applied. For example, for a situation where the human impact on climate change is being measured, an appropriate unit for T might be greenhouse gas emissions per unit of GDP. What we really need is decoupling. Here, decoupling means using less resources per unit of economic output and human well-being, and reducing the environmental impact of the resources used and the economic activities undertaken to increase human well-being. The figure captures the essence of the two aspects of decoupling as applied to sustainable development, namely resource decoupling and impact decoupling.